Okay, thanks everyone for connecting to the seminar. Just a brief, a few notes on the HSF seminar series in general. If you're new to the HSF seminar, there's more of a description on the agenda itself, so you can find out there how to subscribe to the mailing list, etc. We don't have any fixed dates for future seminars at the moment. The last one, unfortunately, was had to be postponed short notice, but we hope, which was on HS3, but we hope to have rescheduled that one. And in May, because of CHEF, we won't have a seminar in May. Okay, so then going on to the main topic of today, which is the ICFA Data Lifecycle panel recommendations, which is by our speaker, Kati, from the Helsinki Institute of Physics. She is an experimental physicist and also she had previously led the CMS Open Data Initiative for its first 10 years of existence, and is now the panel chair of the ICFA Data Lifecycle recommendations panel. And she will obviously tell us a lot more about that. So you're free to go ahead and share your slides.
Okay, thank you very much. So let's just say hello first of all to everyone, then I switch off my camera and share my screen. Okay, you should now see my screen, right?
On our side, it says, please wait. I don't know why it takes so long. There we go.
Okay. So thanks for the opportunity to present the recommendations for data preservation and open science. Now domain, which we drafted for ICFA in the ICFA Data Lifecycle panel. Let me start. Right. Let me start first at a few statements that we do have great progress at this very moment in data preservation activities. There's continuing and renewed interest, the emerging tools, and we already see the scientific impact of using the preserved data. There was a very nice article in CERN Courier. If you click on the figure, I think it's a link. It's showing all these facilities, all these experiments that have been taking data or are taking data, and how much data they've stored and how much of it is in use. And also we had a DP-HEP data preservation in high energy physics collaboration workshop recently in March at CERN, and there we saw again surprisingly increased interest and very wide interest in different countries, and very, very interesting presentations, but I won't be able to go to those, although I invite you to have a look. However, I think it's good to think that what makes data preservation and open science happen. So we've seen there's lots of things that are being done. Is it a structured approach, or does it somehow just happen by magic? So by people who are there, which happen to be there with goodwill and necessary skills, in such position in their career that they can decide to do what they believe should be done for data preservation and open science to happen. And they do it despite of challenges, and those challenges are related to resources. So whether we have sort of resources as a community and whether they have resources to doing this work. Also the time constraint, because rarely anyone is actually paid to do the data preservation and open science work. I think we have to admit that these kind of activities are not necessarily the sort of the best thing you can do to advance your career. And even if all these three first sort of factors are in place, there's also the last one, which is kind of resistance, I would call it. So to try to make things done in a way that data are preserved and they remain usable often faces resistance by our own community. So in first part, I would like to explain a little bit that how do we overcome these obstacles? Obviously, we don't want to sort of do away the magic. I think it's very inspiring, at least the people who are inspired by data preservation, to see things preserved and in use. But we want to make that magic in a way that it is possible for more people to take part in this endeavor. So first of all, a little bit, who are we? So I'm talking on behalf of Data Lifecycle panel, which has been set up by ICFA. So ICFA is an International Committee for Future Accelerators, and it is a high-level committee with lab directors and regional representatives. And the way of working of ICFA is that it sets up working groups that they call panels on different topics that they consider should be addressed in our domain. So already the fact that we do have such a panel, and we have DPHEP, which is first emerged as a panel, means that there's sort of a concern in our domain that these things need to be taken into account. So the ICFA Data Lifecycle panel, we have a mission which is quite impressive. So we should enhance global coordination on all possible aspects of data lifecycle with a focus on open science and fair practices. So we do have a very, very challenging mandate. And there we picked up as a first activity. This panel was started 2 years ago, and as a first activity, we picked up formulated recommendations for open science. To do this, it was not only the panel members, but we called an editorial group. So experts, people who are doing hands-on work with the preservation of high energy physics data. And we called for volunteers to DPHEP, also HEP HSF training, and open science, what we call service providers in the community. So it was sort of the voluntary work for, and people who were involved were really sort of felt the need of this kind of recommendations. And we did release these recommendations. First of all, I think I should say the goal and the current situation in HEP. So what we sort of the goal of such a recommendation is always like it is really the long-term scientific usability of experimental data. And if we look, what is the situation in our domain? I think we are very strong in open access publishing. That's something we do really very well. We do make very good progress in open data. It's something that is becoming more and more a standard. But where we are doing really not very well is we do have big challenges in preserving the analyst knowledge, the workflows, software, and contextual documentation. And why this is important is because we are interested, it's not only preserving data, but it's to preserve the knowledge how to use them. So all this feedback to the usability. So that's a very important point. And you will see that it is something that really drives the input in these recommendations. Also, what we need to take into account that in the sense we are particular because we have huge experiments and there are many stakeholders. So we take the researcher is in the middle, but he or she can only act if all sort of factors that affect their sort of margin of maneuver are in favor. So home institutes give tasks, definitions, resources, education, training, but it's actually often your experiment and your working group that gives the actual tasks, responsibilities, and the concrete resources with which you work. And very importantly, the practices. So how do we work? So it builds sort of the way of acting in this context. And then we have a host laboratory, which gives infrastructure and resources. And all these stakeholders have different kind of research data management guidelines, policies, open science guidelines. So why do we need yet another layer of recommendations? We already have so many of those. So the design principles for these guidelines was they have to be concrete to the reader. So they must use clear practical languages instead of high-level terms. It often happens, and it happens naturally, and there's nothing wrong with it, that many of those policies that are written by the universities or national entities are very generic. And sometimes it's really like gymnastics to try to match the text to what we understand. So the goal of these recommendations is to be very clear and concrete. Also, they need to be specific to our domain. So we wanted this to be specific to large scientific collaborations, and we allow ourselves to consider domain-specific tool and practices. So we do not pretend to be like general to all domains. And also, as shown, there are many stakeholders. So we need to, for the recommendations, for each recommendation, we need to indicate the audience. So who is the audience that actually can take action reading this recommendation? And we want to use proper terminology for the reader. So this, we hope, that makes the recommendations actionable. And what we came out was an archive note and a kind of a web app where you can sort of more easily access recommendations. And this was really very nice group work. You can see here a list of contributors, and I think we all did a pretty good work to come up with this document in it took us a year or so. So you can you can go and have a look after my talk, please, and what it contains. So for now, I just show the important features here. So, oops, sorry, for the best readability, it's advisable to choose an actor. So think, who are you? Who are you? If you're an analyst, you click on analyst, and you see a list of recommendations where an analyst can take action. And for each recommendations, there's one short, normally fairly short recommendation sentence and a motivation or description when needed. We also have executive summaries. We do have separate summaries for all of these roles, because we cannot the same summary is not valid for everyone. And we do have glossary links, contributor list, and so on. So for the key takeaways, so I repeat, the main goal is really a long-term preservation and scientific usability experimental data. And I think my view of the key takeaway of this recommendation is that we must consider analysis software and workflow description as an integral part of research outcomes. So we have publication, we have data, but software and workflows are as important. Also, we need to acknowledge that there's a lot of supplementary information and contextual knowledge that is needed for understanding these data in long term, and they must be preserved as well. And also, to do is sort of smoothly, people will need to have the software skills to follow these practices. And this is where obviously we do rely on the work which has been done in HFS training. And then last but not least, there must be policies and resources to support these practices. So I picked few things for you. I'm not going to go through in very much detail, but just to show what kind of things we have on each of these key takeaways. For example, one important thing which is going to probably cause some discussion, that we recommend that there should be an ultimate goal of making all research product, including analysis code, open. This is not something that collaborations are doing now. This has not even been discussed, but I think it should, when we talk about open science, we cannot really do it honestly if we do not consider this as an ultimate goal. There's a caveat what we are not proposing changes to the data release models. So data releases with an embargo period. So this is about releasing code as unambiguous description of analysis methods. So this is actually where many of these recommendations try to bring to. Then there was a key takeaway was that supplementary information and contextual knowledge need to be preserved. Much of it is informal documentation. So we have lots of recommendations that say provide, encourage, preserve, require, recognize, keep accessible. So there are lots of things we really need to keep track. So this is also important with any sort of a programmatic access and even any future AI approaches, that we do have a solid collection of correct information. Another part of this supplementary information are different kinds of databases and metadata that we need in order to analyze the data correctly, and they need to be preserved as well. And they need to be preserved beyond the lifetime of the experiment. So we need to think about it now. If for the ongoing experiments need to think what are the things that we need to preserve and how we're going to preserve and keep them usable in long term after the lifetime of the experiment. Then I come to software skills, and this is something that are very well known to HFA training. We do have like very down-to-earth things like use code versioning and commit changes frequently to a common repository. Why do we go to such a detail? Is because if this is not done, all actions that have to do with knowledge preservation and analysis preservation just become impossible. If people do not work proactively in the way that the data can be preserved, that the analysis code can be preserved, it will not happen afterwards. So we do have quite a lot of recommendations on software and workflow management skills, and also analysis preservation tools and practices. And there we have, for example, there are certain things that rely on experiment management, taking decisions. Again, we have verbs like provide, encourage, require. It's because this is needed in order for the analyst to be able to preserve their knowledge, which is then a different set of recommendations. And then, yes, if you look a little bit through, you will certainly see that there are common points, and there's actually very productive overlap with the HFA training initiatives and IVERS activities. And Katerina will say a few words about them. I think she and Stefan have had a very nice look on the synergies that might have. Right. So I think the message that we need to pass, however, because sometimes people are not motivated by the long-term preservation, but they are motivated. What happens is to respect open science and fair principle in your own software development. The first to benefit is you. So better software skills, more time for research. Then the people around you, for example, in a working group. So you can share tools, you can share knowledge, faster integration of newcomers in the working group, and so on. And then it's the community, which I would say in our context is the experiment. So easy to find, develop, and use common solution, better efficiency, reuse of the tools. And only after that, it comes to open access, everyone, open access publication, open data, open source software, open methods. And important thing that we need to consider that this open science is not something that just happens. It just doesn't happen by magic. It's not done by someone else. We need to build into our working methods, that working practices that everybody thinks of let me do my work in a way that is easier to share with my colleagues. Right, so we've done with the recommendations. So what's next? So this is well, we want to assess what's the situation. First of all, we want to make the recommendation known, and then we want to evaluate how different actors implement these recommendations. What's the current status? And then we want to report and share solutions. So first, discuss. That's what I'm doing here. So discuss and present the things in the community with seminars and presentations. And as it often happens, as you notice, that with these presentations are very important. I'm very happy to be here to present, but it's not that we attract people who can make decisions, very rarely. So there has to be another way to bring this message to the people who can take action. So we want to assess, and the assessment really means that we contact every experiment and laboratory, and we ask them to go through the recommendations and say how they're doing. So we want to start with the decision level actor groups because their actions make possible the actions by others. So we start with host laboratories and experiment management, eventually with funding agencies, not directly to the funding agencies, but maybe through the national or regional committees that provide input to those. So again, a little bit of the design principles for this assessment. So our main goal is really the impact. So we want to reach out through the high-level management because they need to think about these things. We're talking about data lifecycle. We think about decisions and way of working that can be done now, but they do have an impact in long term in the future. And we also want to request verifiable information, so not just yes and no. And then the second point is reuse. So we want to do this assessment regularly. So we want to store the responses to be compared to later on, and we plan for regular assessment rounds. And then, okay, well, there's a fairly important factor is good user experience. So we want to do this in a way that it's we don't want to frustrate people. We just want to make them think of these recommendations and see whether they have done or not. So that requires a little bit careful planning and proper tooling. So the impact that we hope to have, we want to increase the awareness at the decision-making level and reach out to high-level management. So for example, for experiments, what we call the assessment team, an evaluation team will not be a single person, it should be a team, but it should present the experiment management, as we say in CMS and appropriate LHC, the level 1 management. So we collect that information and we report back to share the solutions. So what we want to have verifiable information. So for each recommendations, there will be options applied, partially applied, planned, not yet considered, not applicable. And for those things that are applied, we want to have links to the relevant information. So if there's a decision, it should be a link where this decision is made known to the people. And when things are planned, we want to see the timeline so that next time when we do the assessment, we can sort of follow up on the schedule. So obviously, when we talk about decisions and information within the experiment, links can be internal, that's not a problem. But we do want to invite some collaboration members to verify the findability and accessibility or relevance to those links. And they can then report back to the assessment team who may update the responses accordingly. So what we want to use this information is, well, maybe in the future, if everything goes well, we could build an experiment-specific recommendation facet if desired, where we could give the collaboration members, for example, or the collection of different decisions, mandates, guidelines, or instructions. And obviously, the other thing that we can improve and update the recommendation if needed. So this is just a screenshot what it's all about. So there's a recommendation and there's a sort of option where one can choose the different options and then the text field to build in to give the input. So what we hope for the outcome. So as I say, really the main important thing is to raise the awareness, make people think that have we agreed to do this, or if we have agreed to do this, this is something that is documented so that people in 2 years will know it. And that's why we also want to do the regular assessment rounds at 2 years interval to match with the typical management change in the collaborations. And when we start this assessment, we start with an introduction session to these people, and we try to highlight the benefits, because we know in each experiment there are lots of people who are doing a wonderful tooling to make for example, this analysis preservation concept easy to do. Then once we collect this information, we'll report. So we will write a public report where we focus on overall picture. So why certain actions are not taken. So we saw what one of the options was not applicable. So people may say that, well, no, we're not going to do this because we think this so, or not yet considered. Why didn't you consider it? Maybe because you didn't even think about it, or you think it's impossible, or it will delay your applications, or whatever is the reason. So we want to collect that information why certain actions are not taken, so we can identify common challenges. We want to highlight successful actions. So if for example, one experiment is doing well and have nice solutions, that's something we want to highlight. But we do not want to put emphasis on specific shortcomings, because we want to keep the impact positive. So we don't want to do any public shaming. And also the first assessment round is also a learning period, even for us. So what we want to have as an impact so we want to monitor the progress. So we want to compare to the previous rounds, see if things are improving, and we want to encourage a change and also keep the impact positive. So I think I'm already in my summary. So we came up with the recommendations which we think are concrete, specific, and relevant, and they should be actionable by the reader. And I think the important concept that they're really co-created by the community. So this is not something which is imposed to us. This is these are reflections of people who have been involved in this work and know the trouble to keep data reusable. We've seen that the recommendation is well aligned and complementing the work which is done in HSF and in EVERS projects. And the assessment process, which is starting soon, I hope next month. So we want to raise the awareness, so reach beyond the usual DB-HEP community, HSF community, just to the people who are not sitting and listening to my talk here. We want to share solutions, show that things can be done different, that's a certain experiment, for example, is doing. We want to improve, so encourage actions, and we want to measure the impact. And I think finally, the outlook, ultimately, what we should think of is the really long-term future, where this great progress that has been done for data preservation and data reuse has often relied on the fact that there was someone around that people could ask how these things were done. We might well be for the next generation particle physicists that there will be no one around. So we just want to take the right side of the history, not the left one here, so that the people said, well, we have this data, but nobody knows how to use them anymore. Or we can choose to work now in a way that this awesome data knowledge from our times are properly preserved and remain usable in long term. So thank you. That's all I have. So I'm happy to discuss and take your questions.
Thank you very much. It was a very nice presentation, and I hope you gave the idea of how much work goes behind this. It's not just coming up with recommendation. It's also iterating with a very large community. It's putting the app together. It's writing the whole document. So it's good to have this discussion here at the HSL, especially because they are very well aligned with the things that we're talking about in terms of project affiliation. Now, I wanted to, before I go to the more HSF specific part of this, I wanted to open the floor for questions and discussion, both from the room. I don't know. At least two, I see. Three. Yeah. So anyone having questions on something? Sorry, not on Zoom, on the room.
There's one in the room.
Hey, thanks very much. Indeed, one question. I think you more or less answered at the end of your talk, but I think you started in page 30 when you mentioned how you're taking actions, and it seemed like at the beginning, often is bottom up, but now, do I understand correctly that it's work in progress, meaning you would like to go top down and actually get in touch with the management for the experiment and so on to get things going in practice? So that has not happened yet, right? That's what I understood.
No. Yep,
Okay.
we'll start the assessment, the evaluation round. We will contact the experiment management, so spokesperson, and also we do it at the laboratory level, so that at CERN that will go through the Open Science Office, and so this is well, we've been a little bit of working on the tool, because we're in order to be able to reuse the thing. It's a app and not just a survey, so it's something that stores in a database itself, and we want to have it sort of again something that is not too frustrating to fill in.
Yeah, thanks. I also note something that probably you can use in your discussions, because at some point very early on, you mentioned HERA in your diagram. I think it was one of the first three or four slides. And for having been on HERA in very old times, it is true that HERA is a very good example. They worked quite hard on data analysis preservation, and they were still doing a bunch of analysis throughout at least a decade after the stop of the accelerator. So they had actually a success story that can be told. It's not like we're going to be trying this for the first time in the LHC. And I think this is worth emphasizing. Okay,
definitely.
thanks.
Yes, at the DP workshop we saw lots of these things, lots of even now from lab experiments we thought that would have been still lost forever, but no, they are new analysis being done on the on lab data.
Okay, thank you.
Any more questions in the room?
No.
Seems not. So we have Heidi on Zoom with a question.
Yes, let me see. Actually, I'll turn on my video for a second. So I am the previous Dune software and computing organizer, and am also part of our training group. And I am very interested in trying to make the Dune data that's going to come out open. And I just want to point out that if Dune sees a supernova, or any of the other large neutrino experiments see a supernova, that's only going to be the only one we see for 60 years. So we need to really work on astrophysics quality data preservation, and open data in the long run, because in astronomy, the idea is that the data become open after a reasonably short period of time. So introduction. So the question I have is, how do you get a collaboration as a whole started on this? We're having trouble getting our people to realize that we really do need to make open data. So a question is, how do you get people to buy in just at the beginning on the fact that the data is going to be public and that this work should be done.
Right. Well, I have a personal story because I was involved in the very first. So in CMS, and we were really the sort of the piloting. It was 2010, 2011 when the collaboration board decided that we need to have an open data policy. Then we made that open data policy. It was released in 2012. And the first time it was presented, when I was presenting it at the collaboration board, it was shock and horror. So it was something which is because it was new. And so we had to go sort of quite with sort of a low profile, showing that nothing bad happens. I think the same arguments that people were making at the time, they pop up. Erina, what will people do with our data? We will need to spend time to demonstrate that their crazy ideas are wrong, all those things, and that has never happened. And I think in CMS we did the regular releases increasing every year, and that helped to show that okay, well, this is something that can be done with. Compared to the full experiment for reasonable person power, and compared to the sort of full budget, which CERN, in our case, provides a storage budget, and that was very helpful. So I think it began with fairly small resources compared to what is being done. And at CERN, the management picked up that thing, and we got an open data and then finally open science policy, and that. Now I think it makes this sort of work easier in a sense that at least it has been decided. It still needs to be done. It's not automatic when you do a policy, when you do a decision, but at least once a decision is made, then you do not have to spend the energy of rediscussing these things all over and over and over again, because that's very time consuming, and that's mentally also very consuming, because people who do the actual work to prepare the open data releases, for example, it's not that well, it's a decent amount of work, and either you do the work or you do the PR. So you can't do both. So if you're low in resources and if you don't want to get things done, you just have to do the work. So you can't spend your energy on rediscussing things all over again. So that kind of policy decision once and for all in the collaboration board level. So you can refer to that. It's just okay. You can then say, we discussed this once, we've decided, and we do it. It's not that it makes it like automatic. All the releases are get an approval, but still it's sort of the baseline decision that yes, we're going to do it. This is very helpful.
Okay, thank you, because actually I'm speaking to my spokespeople in an hour about this. It happenstance that these two meetings converge.
Okay, very good, very good.
Yes, I'm also a part of Minerva, so I've seen it on the other side.
Okay, so we probably come to you as well with our assessment at a certain point.
Yeah, we're going to try to. It's non-trivial right now. I'd say it's more data preservation at this point, but we'll get there.
Yeah, I think what is the important topic is that we need to people need to understand that this is useful for the collaborators. This is useful for your colleagues. And this open science does not happen if things are not fair internally. First, they have to be internally, and internally they are kind of immediate or short-term, or at least medium-term benefits, which one can, because finally we all go through that. Where did I put my code? It's that simple. It's not like keeping things well fair means that you can find them, and you can find them yourself. So that's increases the efficiency, working efficiency.
Yeah, I will say that the personal experience within Minerva's vastly more effort went into the final data samples than would have happened if we had not done the open data project. And it's kept the enthusiasm of the young people on the experiment going a lot longer. It's been hugely beneficial to Minerva as a scientific experiment. So I will mute myself and let somebody else ask a question.
I was just going to say to use, the way you were emphasizing, we just have to do the work. And I think it's also, it must be important to also do the work now, because the longer you wait, the harder it will be to go back and try and preserve that data. And I was wondering with the current CERN open data policy for the LHC experiments, do you think that's sufficient the way they, I mean, I unfortunately can't remember the exact terms, but it's like 10% in the next years, and it seemed little to me at first. Like it's a very slow progress.
Yeah, the parameters depends on the experiment. So that's kind of the CERN has a policy that everybody has. The LHC experiments have to release open data, and then the sort of the parameters, the percentage and embargo is then by the experiment. My personal experience is that it is very important that part of the data gets released fairly, not soon compared to the other domains, but in a reasonable delay, because otherwise you just don't know anymore what things are. So preparing the releases when these data are still internally in use, because otherwise we just lost.
Yeah.
Any other questions from anywhere? No? So I have a brief attachment to this talk. This updating the HSF and the audience on what has happened after the data recommendations were prepared and how they map to HSF affiliate projects and what we can do going on in the future. So there's going to be a part that is in slides and a little part that I wanted to discuss with you afterwards. Let me share. I hope you can hear me. I hope my earphones don't die while I'm speaking. It might happen. If stuff happens, just give me a second. The different there. You should be seeing the slides now. I'm just going to get through the whole thing. Okay. All right. So this is about mapping software quality across communities. And
you go down there that way. I'm gonna ask you to go down.
I have input from a few people, and we're not talking just about the ICFA Data Lifecycle. Here, there's also the eBirth project that people are probably familiar with by virtue of seeing it in a number of WSG HSF workshops. Just as a reminder, you've just seen the ICFA Lifecycle recommendations. Now we're fresh on it first. And this is paving the way towards a European Virtual Institute for Research Software Excellence, which is more or less in place, I think, at this point, because next year is we have left. It wasn't a long project, but it's coming through. So what we've done is create a framework for research software called Excellence that was co-designed by the research communities towards a network. And I see that John is in the audience. He's one of the main players in this network. And then hopefully in the future, that's the last stage of this presentation, this will be sustained through the European funding for goodwill of people, but that's better to have. So what does it do? ensures that there's a software curation. So it doesn't necessarily curate the software itself, but there are guidelines on how to make this easy. And so software should be curated, the quality preserved, and best practices should be adopted. The idea wasn't to make up best practices, was to collect best practices from various communities. And the 5 EOSC science clusters, this is the European Open Science Cloud. The science clusters, there's everything ranging from us, physics and astronomy, to social sciences and economics and life sciences. Basically everyone who's doing some sort of work with data, even with non-digital data, is in the science cluster. So it's a really key. So there's a quick-clear model for research software. There's analysis code, prototype tools, a bit controversial. We'll see that later. And research software infrastructure, because there's different kinds of software. And in the ICFA Data Lifecycle recommendations, we don't have this distinction, but we have the distinction between community software and experiment software. But the point here is that everyone knows that there's different kinds of software, and they should all be treated with the same sort of recommendations. Right? The other thing that IVERS does is try to put the predicate recognition system in place. There's going to be a seminar. I think I will either has already been forward to HSF, or will be forward to HSF to see what IVERS is doing in that sense. So how does it work? There's the kind of fulcrum of this has been for the first beginning of the project is the research software quality chain. And this is the concrete output of commonly applicable practices, and this is going to be our starting point for the mapping of best practices because it contains a task-driven guide how to improve research software quality. There's also tools and services, so pipelines, quality indicators. So I'm not talking about that. But this is another aspect. So how do you actually measure that your software is doing a good thing, like having a license? There is a license, but this is just a simple example. There's other things you can check. And then informing and testing all of this, both the RSQ kit and the pipelines, is the IVERS pilots and drivers. So this is actually software packages from the communities that are going through the RSQ kit, finding out what's best to do and testing it out. So we now have the full picture, more or less. So we know what the HSF affiliated projects are. We know the ICFA guidelines, and we now know what the RSQ kit does. And they are complementary. So there's different aspects, and somehow these are mapped to the indicators that of quality of software. But there's a sustainability aspect. So ICFA is, why do you want to do it? It's because it's essential for long-term data software preservation, future use. HSF somehow says how to do things. So what are the guidelines that a community-driven project should be following, for example, to outlive single developers? So how do you make software live on? And then the RSQ kit tells people how to do this. So it provides tasks to make software maintenance easier for others, or usability for others, increases usability for others. And this is all, I'm not going to read the whole table, but this is the point, that ICFA says why and somehow what to do. The HSF defines how to do things, and the RSQ kit tells people how to do things. So if you take now, this is going to look very, very small, and I'm not expecting a completeness. How do you do mapping across these efforts? Because each one of these has recommendations or tasks. So you can map one to the other. And you want to see the full image, there's a Google Docs link. So note that this is a bad UI UX. I do not like this, but this was the quick do it. Maybe if we want to portray this in a more sensible way, we can think about what it looks like. But this is just to understand what maps to what. And then in practice, how we use it is that we have done a test joint HSF ICFA/IVERS review. This has happened to both Mark and Petya. Sorry, the link is not there. I'll pick it up first. So Stefan and I, and also Johannes, have been acting as reviewers for the project that wants to become affiliated. And we've started doing the HSF review first, and then after that, we've mapped the review outcomes to the ICFA Data Lifecycle recommendations. And this is the one that are the ones about community software, because this is not collaboration specific software, this is community software, and then check the points that this software was following. Now, is this part of an entire data lifecycle assessment? Well, probably not, because CLICA doesn't have to do with experiment data, for example, but it's part of, if your experiment uses CLICA, you probably have these things. You should have these things somewhere so that you read what this experiment, what the community software has done that you're using, so you pick it up. And I think there is most things are there. Some things are not necessarily clear how to implement it. What does it mean that application should give priority to open source software and tools? It's not necessarily something for developers. It's more for other stakeholders. But we have it there as well. In general, yes, there are packages that are used, but it's right there. Or you want to read it as the MapGraph software has many citations, so you should prioritize that. So that's where there was a little bit of question on what we do there. But yeah, generally, software criteria for HSF will also hit most of the software criteria for ICFA. So now moving on to what we're doing in the HSF website regarding ICFA. There's a PR to be reviewed. There's actually two PRs. One is Eduardo's and one is mine, but we have them open in parallel and we'll merge them later. Is to make sure that we have this why, how, and how to distinction, and we make the community aware these three efforts happen. So on the HSF affiliated projects page, we have text and links to the data lifecycle mission, mandates, recommendations, app. And we have this text that these affiliated projects also align with several of the software-related recommendations from the ICFA data lifecycle. So I think this points to the connection between the two. And then we could also mention on the data lifecycle part of the website, the HSF affiliated project, so that someone is from an experiment is going to look at, well, I use this particular community software, how is it doing? Then it goes, they know that there's a review, someone has to make a level. And that's basically it. So that's my ending. Now, one thing that I wanted to leave, probably maybe in the minutes, but I didn't slide on, is that there's a discussion on how inverse and all the work that has been done by HSF lives on in the future. And the tool that will be used is possibly the Oscars funding call. This is a very, very large grant, so there's a lot of people involved. Very, very large. It's not very, very, it's a significant amount of money, but it has to be divided into many different smaller pieces because it's everyone doing any kinds of sciences in the European community. So it's not something that can sustain an entire effort, but it seems like the sustainability of this, with the guidelines, the RSQ kit, and the pipelines will be coming through making sure that these are integrated in the software communities of the different science clusters. And this is work that we're actually doing in Universe. Now, whether this is going to be something that can support the HSF somehow, this is something I'm thinking about. I've not yet made a move about it because I need to see how it looks like. But, people might be contacted about that, especially the steering group. So it might be that this connection actually helps. Well, we provide a service for the community in doing these reviews. Is this recognized in some way? Hopefully so. But I think this is something that is good for both the projects and the HSF, that we keep providing the service and we keep sort of certifying humanly, like by a human, there's a human certification of the value of community software. So that's it. That's what I wanted to say. And, I'm happy to take questions.
Thanks, Katerina. Kati, go ahead.
Yeah, thanks, Katerina, for the nice presentation. I think this is a really important topic that you mentioned, that what is sort of the who takes over the work, because there's lots of work that has been useful work that has been done, very nice toolkit to define what are the different steps. But in order for us, for example, if we want to make these recommendations evolve in the way that they also point to some resources, we need to be sure that those resources are persistent. So that's always a difficulty when work is done with the projects that are funded a certain amount of time, is that who takes over the outcome, and that's something we, as you said, needs to be taken care of.
Yeah, I mean, I agree with this. It's unfortunate these kind of projects are not, a base ground kind of thing, but they need to be done. So it's up to somehow members of the community to say, well, I see a way to let others get funding, because I think this is an important point. It's not like I want the funding myself, but it's like this community needs to be supported. Let's see where the effort should be going, and let's make sure that the effort is going in a way that where it ensures sustainability of the effort rather than sustainability of one's postdoc somehow. So this is a bit difficult to do, but I hope that I think the people involved are all the same. Okay, I don't know if there's any other question. I'm sure that we'll have other times that are not late at CERN to discuss the PR. I mean, it's on GitHub, it's linked by the slides. And yeah, there's going to be more discussion between IVERS, ICFA, and the HSF in the future for sure. But it was good to make this connection today. So thanks, Kati, again for giving this talk. And with this, I think if there's nothing else, we'll probably close the seminar. I'll leave it to Claire, who is the official seminar keeper.
Okay, thanks. Yeah, so that's been perfectly on time.
All right.
Yeah, I look forward to future discussions as well and seeing changes in my experiments as well. Thank you.
Okay, thank you,
very much.
everyone. Bye-bye.
Bye-bye.
Bye-bye.